Now that we've gone through the Bio-Rad assay and determined what the protein concentration is of the various samples, we have to figure out how to dilute those samples to make them equal in all the wells, lanes that we put them on the polyacrylamide gel. So here's an example of a sample that has 6.3 milligrams per mil. We want to dilute that down to a concentration of 0.71 milligrams per mil. How do we do that? If you take 0.71 and divide that into 6.3, what you're going to get is a number that is 8.8. We go through the division process. So the dilution is a 1 to 8.8 dilution. If you divide 8.8 into 1, you're going to get a 0.11 number. And what this means, if you multiply that times 100, what this means is that if you take 11 microliters of the original sample, the 6.3 milligrams per mil, and add that to 89 microliters of your buffer solution, this will be a 1 to 8.8 dilution, and this will give you then a solution that contains 0.71 milligrams per mil. So that's how you would dilute the sample. From the solution then, we need to add our sample to a stop buffer solution, which I will show you, and boil it, and then we'll add it to the polyacrylamide gels. So once we have all the dilutions at 0.71 milligrams per mil, we need to add our samples to this sample buffer solution, which is a 4x concentrated solution. In order to get the sample buffer diluted to 4x 4 times, I'm going to be taking 25 microliters of the sample buffer, adding the sample buffer to each tube, we'll add 25 microliters of sample buffer each of these tubes, and 75 microliters of the samples, the diluted samples, each tube, and then we will boil these for 5 minutes. So I've added the 25 microliters. Now I'm starting to add the 75 microliters of samples. Make sure that they're vortexed. Change tips in between. The purpose of the sample buffer is to help preserve the enzymes, and also it contains glycerol, so that when you add these samples onto the polyacrylamide gel, they are going to move to the bottom of each lane. So glycerol is heavier than the buffer is. So we vortex this, put it in a 73-degree bath. Leave it here for 5 minutes, and then we'll add them to our polyacrylamide gel. The next step after the boiling of the samples is to prepare the polyacrylamide gel plates. Now these are precast gels as opposed to having to pour your own gel. And these are precast gels for our mini gel system. You first have to take the precast gel out of the packet. You should always glove up because polyacrylamide itself is a neurotoxin. This has a sealant down at the bottom here, and you need to remove this paper. And what this does is it simply prevents the bottom of the gel from drying out. So there is a space here at the bottom which allows the lower buffer, as you'll see later, to come in contact with the gel. We want to rinse this off with the ionized water. And then very carefully we want to remove the combs from the top of this gel. And these combs form the lanes to which we're going to put the samples into. Now this gel is going to be notched. There's an inside that we just pulled the combs from, and when we place this in the gel holder here, the inside notch area needs to be on the inside. So this gel will fit into this holder. There's a rubber gasket around here to help seal it. But we put this in, and what I'm going to do also is to, just to make it easier to see, I'm going to mark the bottom of these lanes so that I can see where the sample is going to go. So this is one gel, and for this run we're going to use 2 gels. If we didn't have a second gel, we would use a dam buffer, which is just a clear piece of plexiglass to go on the other side here to create the reservoir. So we take this out, and again peel the paper off in the bottom portion. Rinse this with the ionized water. Again, we'll mark these lanes. And if you also want to put a number 1 for the number 1 side, that might be helpful. We pull the combs out gently because if you pull them too fast, it creates a suction and the lanes kind of squeeze together. And then we set this up on the other side. So now we have these on the form. what we're going to do is slide this into the gel holder. Only goes in one direction. Then we put these triangular forms in, and these are meant to hold these plates in place so that they slide down and create a solid wedge so that the plates don't fall apart. At this point then, you want to just add some of the buffer to the wells of the plate. Make sure these are washed out appropriately. And then we want to fill up the reservoir that's in the center of the plate. So what I'm going to do is fill up this flask with some of our buffer. And pour this into the reservoir. And you want to fill this up to a level just above where the upper portion of the gel is. You want to make sure that there's no leakage of this buffer into the lower portion of the gel. If there is, you're going to have to take this apart, put it back together again, and make sure it doesn't leak. And at this point, if there's no leak, we're ready to add the samples to the gel. And to do this, very nice to have some very thin tipped pipette tips which will actually fit into the well. So what we're going to do is add 20 microliters of these samples here to the wells. Now, one thing you do have to be careful of is making sure you remember which well contains which sample. And you do this very slowly so it doesn't overflow. And about the maximum it can be in each well is about 20 microliters. So we put drain in the first one. I'm going to put spleen into the next one. And I think that you might be able to see that because of the presence of the glycerol in this sample buffer, the samples just move down to the bottom with the blue dye and stay at the bottom. is again at the point where, as you're adding these things to the wells, if you didn't mark these at the lower portion, it might be very hard to see where these wells actually are. We have our samples in there. And what I'm going to add last is a solution of molecular weight markers. I'm just going to leave a space between our samples and where I'm adding the molecular weight markers. So we have finished one gel. I'm going to complete the adding of these samples to the next gel, and then I'll show you how to run it. So you can see right now that our samples with the sample buffer are in the lanes. There's a space between our 5 samples and the molecular weight marker, and we're ready to run. Now at this point we have both of the polyacrylamide gels set, and you can see here that we also have added now the lower buffer to this system. We're ready at this point then to place the electrodes onto the system, and this only fits one way. The red would be the positive electrode, the black would be the negative electrode. I'm going to plug these into an electrical supply box and turn this on. And we can then run this at constant voltage, and in a short time you should be able to see that the samples are condensing at the bottom of each lane, and you can actually see at this point some bubbles rising up, which means that the electrical current is going through. As you can see now, the gels are moving down. It's been about 15 minutes, and we'll probably give it another 15 minutes to a half hour, at which time the die front should be at the bottom. We'll take this off, and then we'll initiate the transfer to nitrocellulose. As you can see now, the die front is right down at the bottom of the precast gel, and I'm about to turn it off. Before I do, just want to show you what this is here. This is the power supply, and when we run a gel, as you can see here, we're on constant voltage, and the volts are at 200 volts, and if you keep it at this setting, it's only going to take about 35 to 50 minutes for the gel to run all the way down. You can also run it at constant current, but we do not need to do that. The adjustment button is here, and you can see the electro wires that come down into the gel setup. In preparation to do the transfer of the polyacrylamide gel to the nitrocellulose, we need first to cut out some filter paper squares, and we can do that by just taking a template from one of the blotting pads that we have and cutting the squares out. For each gel we need 4 pieces of filter paper cut out to the appropriate size. This is just regular Wattman filter paper. Then we also need to cut out the nitrocellulose paper. Now the nitrocellulose paper is surrounded by just a protective blue paper. You don't want to get proteins onto the nitrocellulose because the nitrocellulose itself is very avid for picking up proteins, so wear gloves on your hand. And since we have 2 gels, we're going to need 2 squares of nitrocellulose. So now the gel is run. We're going to take the gels out of the box, and you first have to remove the wedges. Take the cassette out. And you can rinse it with deionized water. Again, you can see that this is just a plastic cassette. We have a handy-dandy little knife thing, and what you have to do is with this cassette, there are certain areas that are adhered together, and you want to put the knife in and crack the cassette open. And when you do, the gel is going to generally stay on one side. I hope. And if you take this apart carefully, the gel right now is going to stick to the bottom cassette. So the die front is right at the bottom here. What I would suggest doing also is taking off the top layer of where the lanes were put in, because we don't need that. The molecular weight marker was on now the left hand side, and I'm just going to put a cut just to mark which side that molecular weight marker is on. If you want as well, we can cut off the very bottom of the gel, because that's kind of bumpy. Okay, so we have the gel now. I am going to pre-moisten one of these filter paper squares that we have, and I'm going to layer this over our polyacrylamide gel. Then as I take this cassette now and put it into a buffer solution, the gel itself comes directly off right onto the filter paper. Sometimes it may slide around a little bit. I want to make sure that gel itself is square on the filter paper. You can actually pick this entire piece up. And we're ready now to put it in to a cassette for the transfer of the gel to nitrocellulose. In order to set the cassette up, the cassette is this piece here. You need to take 2 blotting pads, put those into the cassette. Next we put a piece of filter paper down. And again, it would help to pre-moisten this. Put it into the cassette. To make sure it's as smooth as can be. Then we will take this piece of nitrocellulose, pre-moisten it, and put the nitrocellulose on top of that filter paper. Then we take this gel, put it upside down, and put it so that it's facing the nitrocellulose with a piece of filter paper on top. We take another blotting pad, stick that on top of the filter paper. Another piece of pre-moistened filter paper, put it on top of this pad. Take our other cassette, crack it open. Pull that back carefully. The gel sticking to one side of the cassette. Again, we can cut off the lower portion of this gel where the die front is. You can remove the lanes from this, mark it as to which side the molecular weight marker is on, moisten filter paper, lay this on top, and then you can again separate the gel from the cassette right onto the filter paper. as such. Take, again, the nitrocellulose transfer membrane. Moisten that. Put the transfer membrane into the cassette. Place the gel and filter paper again on top of that nitrocellulose. And add
You don't want to be
2 blotting pads. And then we seal this cassette. Then place this cassette into the transfer apparatus. Place the wedges into the transfer apparatus. Push it down so the cassette is tight in there. And then we add a transfer buffer, which is different from the running buffer. And we fill this all the way to the top when we fill the cassette with this so that the blotting pads are covered with the buffer. Then again, we put the top on. Hook this up into our power supply and turn this on, and turn the power supply on, and we will begin our run. This transfer should take only about an hour.